Hello guys, am I audible? Am I visible? Okay, I think it's working. So let's start today's class, which is on serverless architectures. So to understand serverless, first let's understand how applications are deployed traditionally up until now. So let's go to eraser. Let me share my screen. I hope my screen is visible. Yeah. Okay, so generally what we do now before this is that let's say we have a Node.js app which is an public API. It is deployed on virtual machines on the cloud, short form VMs. These virtual machines are deployed on AWS, GCP, and Azure. So the thing with these virtual machines is that we have to provision these virtual machines for a set amount of time. We have to provision it, and it scales. It doesn't really scale well. So let's go to EC2 in AWS. Let's say I have to deploy my Node.js app. My Node.js app is on GitHub. So let's first we come to EC2, then we click launch instance. Here first we have to give the server name. Then we have to select the operating system, the architecture of the operating system, the instance type we have to select, like which according to our projected traffic, what it should be. We have to set up key pairs for security groups, networks we have to set up. We have to set up storage also, and then we can click launch instance. And even after this, it just creates a VM on the AWS. Now, the problem with these VMs is that they do not scale really well. So what happens is that let's say you just launched your app and you got let's say 1 million users on the very first day. But on the so you provisioned your app after that. So let's say you selected a big machine, which is this large machine, C6L large, C6L 8X large, etc., etc. So you provisioned it according to that. But after the second day, your hype died down to let's say 10,000 users. But still you have these machines provisioned for you, and they are costing you a lot. So let's see the price of the cheapest machine on AWS, which is this T2 Nano. Its price is 0.0085 USD per hour. Let's see what that is in rupees. So let's calculate 0.0085. This is per hour, so we'll do 24 hours for one day, and for 1 month we'll do 30. This is USD. Let's convert it to rupees, which is 562 rupees per month you have to bear, which is the least powerful machine. And also, let's say you under provision your VM. You notice that you are only getting 10,000 users now, so you under provisioned it to a smaller instance to save cost. But again, your traffic shot up. Let's say it again went to 1 million. So now what will happen? Your server will start to choke. It will start to crash. It will cause a very bad user experience even under this cost. So the solution for this which has been introduced in recent years is serverless. So serverless applications, serverless function, what this means is that you just write the code. This is your code. You just write it and just put it on AWS. AWS will handle your infrastructure, server management, network, everything AWS will handle. You don't have to do anything except just write the code and push it to AWS. Now, serverless doesn't really mean that there is no server. AWS just gets your code, runs it in a container on any of the server which it has. So it doesn't really mean that your code is running like in the space. It is running on a server. You just don't have to manage that server. So let's look at the pros of this. Now, whenever a request comes to AWS, let's say there is an incoming request. Whenever a request comes here, this code will fire up and run once. Okay. And after that, it will die down. Again, another request come and again this code will run. Let's say, let's take the previous examples. Let's say on the first day you got a million requests. So this code will run a million times. The second day you got 10,000 requests. This code will run only 10,000 times. And the third day you got 1 million requests again. So the code will run for 1 million times. What you can do is that, so the advantages of this is that you don't have to manage any server, and also you only pay for what you use. Like for the first day you pay whatever the price is for 1 million, for second day 10,000 and so on. So here you only pay what you use, how much of the compute you use, that much you pay. And also this scales really well. At one time, let's say 1 million requests come, AWS will spawn 1 million of these containers and run them simultaneously. Whereas in this case, whereas in the VM case, this VM cannot handle this much load if it is not provisioned, if it is not powerful enough for it. So what it will happen, it will start to crash. But here there is no risk of crashing. And also when it scales down, you save cost because you only pay for 10,000 requests. Now, where can we get these offerings? Like who offers these serverless functions or architectures which you can use? So there are multiple of them. Is this a system design class, sir? We will discuss what are serverless functions and then we'll do some coding. Yeah, so basically it is system design mixed with a bit of code as well. Okay, so what are the offerings with it? So first, the most popular is AWS Lambda. This is the offering of AWS. Next, there is Azure Cloud Functions. And there is also Google Cloud Functions. Google Cloud Run Functions. So these are the major offerings. There are many more like Cloudflare workers as well. So as we looked at the cost of the EC2, let's look at these costs as well. How much does Lambda cost? How much does Azure cost? And how much does Cloud Run cost? Okay, one second. Let's first look at Lambda, which is the most popular. Here you can see that for your first 6 billion for your first 6 billion GB seconds per hour. So what does this GB second mean? Let's say you are trying to create a Lambda function. So you can assign it a bunch of RAM. Let's say you assign 1 GB of RAM to it, and it runs for 2 seconds. So this is called 2 GB second. So you just multiply 1 by 2. So which gives out to 2 GB per second. This is the cost they are referring to here. So for first 6 billion GB seconds per month, you get billed 0.00, which is very less. And also for the request, the number of requests which you get, it is 0.2 dollars per 1 million requests. These are the different pricing for x86 architectures, and this is for ARM architectures. So next, let's look at Google Cloud pricing. In Google Cloud, it is 0.40 for every million requests after the free tier, and for the GB second, it is 0.xxx025. So it is very less, and you only pay as you go. So any app that you want to publish, let's say you have a startup, you have a product. So this is a very good choice because the cost, it will only cost you how much you use. Next, let's look at Azure. You will notice that these pricing are very similar to each other. Yeah, so for Azure also the same, one per 1 million execution, you get 0.2 executions, 0.2 dollars, sorry, and GB second is 0.000016 GB per second. Now, so we have gone through this. I hope you have understood this. Okay, so no question. So let's move on to creating a Lambda function. Let me show you how easy it is. Let's go to the AWS homepage. From here, you come to Lambda, you search Lambda, you click create function, you give it a name, let's say hello world 2. You select the runtime, let's say Node.js. I know Node.js, so I'll select that, and you click create function. Let's wait for it. Okay, so the function is created and you get a very beautiful VS code inside the browser itself. Now, once you have done this, this is your code. You can change it here itself if you want. So let's try to deploy it. Once there is any code, you just click deploy and it will get deploy. Here it is saying no changes because I have not made any changes. So how to access this function on the cloud? So you can just go to configuration, function URL, create function URL. There are two odd types. You have one which is AWS IAM and another one is none, which means that you don't require any authentication. Whenever you go for a production release, please use AWS IAM and configure that. For now, we'll just use none authentication and click save. Let's go to this URL. It says hello from Lambda. I'll also show how easy it is to change it. Let's come to the code. Hello from, let's say, Euron. We'll do deploy. It is deploy and let's reload. It says hello from Euron now. So now that we have done this, you'll notice that for creating any API route, for single route, you have to do these many things like come to Lambda, click create function, give the function name, select the runtime, and then click create function. For this, AWS has created a model called AWS SAM, which is the serverless application model. Using this, you can create your application in your local environment itself. So let's try to create it. For this, you have to first install the SAM CLI. the AWS SAM CLI. You can install it for whatever system you are on. So I have already installed it. Let's go to the terminal. Let's create a SAM project in our local system. Let's go to CD desktop. Let's create a directory. So the command for running initializing a SAM project is SAM init. So it is asking me, you can select a you can pre-select a particular runtime or package type when using the SAM init experience. Which template source would you like to use? AWS Quick Start templates and custom template location. So what we need is first the Quick Start template. So let's select it. It is asking us which template would you like to use. We are creating some APIs, but for now, let's just use the hello world example for simplicity, which is the choice. Let's say type 1. It is asking us whether to use the most popular runtime, which is Python and Zip. So let's say no, we want to use Node.js. So let's say no. Here we will choose the Node.js version. Let's say I choose 16. So the choice number is 13. Let's say 13. What package type would you like to use? So one benefit of Lambda is that now you can also run Docker containers on Lambda, on serverless Lambda functions. But for the now, we'll just select zip. And then it is asking whether you want a hello world example in JavaScript or would you like to use TypeScript. So let's use TypeScript. All these options, you can just say no because it will cost you. Let's give it a name. Let's say serverless X. Okay, so the project is created. Let me just open it in VS Code. Okay. So here we have the project. So let's understand it. The events folder has all your event JSONs. So let's say you want to run a function. You can invoke it using API or you can use this event as well. Let me go to the application I created. Yeah. So here you can see in test, you can see these are events. This is a test event. You can create one, you can edit your saved ones. You can give it a name. So this is a basic event. You can use this to run your functions locally to test it. Okay. So it also created a hello world folder for us because it is a hello world template. It has a test folder inside it. It has ESLint, npm ignore, and this is the main file. This is the app.ts. This is your application logic. There is also a package.json which contains all the packages. You can go through them after later when you initialize your own project. And also because it is TypeScript, it has a TypeScript tsconfig.json file. There is a git ignore, which is obviously there. There is a readme. There is a SAM config. And this is your most important file, which is the template.yaml file. In here, you declare all your functions which you have written in your code, in your directory, this hello world directory, and you can run it. So after, let's actually go through them one by one. The first three are just boilerplate, like this template format, version, transform, and description. Let's not go into it more. Then there is the global object. So in this global, you can keep some environment, some variables which you can use across all your functions. So instead of typing timeout 3, memory size 3 here, you can just declare it in global and then it will add to every single function here. Okay. So, and also one more thing, you can also override it here. So let's say you have declared a global called timeout 3 and memory size 128. But for this function, you need more. So you can just type it here. You can just type it here and it will override the globals. Okay. So in this function, let's say what you have, this is the resources. So in SAM, you can also create queues, etc. For now, we'll just cover the serverless function. So let's say what is first is the function declaration name, then it is a type. What type is it? It is a serverless function. And then there are properties. There is a code URI, which is which directory does your code like the directory in which your code is there. So here we have hello world. So we have put here hello world, the handler. Inside this directory, what is the file name and what is the function name, your main function name. So here we have used export const lambda handler. You can have multiple here. So you can have multiple here. So lambda needs to do let's say export, let's say const func is just console log hello. Okay, so Lambda needs to know that which is the function which you want to run when the API is called. Okay, so the handler is discussed. Let's discuss the runtime, which is very simple. I like Node.js, so I selected Node.js when we were initializing the application. And then architecture also, I would like the x86 architecture. This is the events tab. So in the events object, you can in the events object, you can we have declared a hello world event, which is of type API. So this will become an API gateway through which we can access it over the internet. Okay. And then there is the metadata. We don't need to go much into this. This is because we are using TypeScript. We need to use ES build during build time to convert this into a JavaScript project, which obviously the browser can run. Node.js can run, I'm sorry. And then we define the entry point. Inside hello world, what is the entry point, which is your main app? Okay, I hope you have understood the template.yaml. And also about this output, this is basically some comments, like when you deploy the application using the terminal, you just get this output. Like what is the URL here? What is the URL of your deployed function? Here is the ARN and the IAM role. So let's try to run this. So before running it, let's say I want to validate this template. Like let's say I just put something bad here. So you can use the command sam validate. Remember that sam is the command to use the sam CLI and validate is the command to validate the template.yaml. Let's run that. Let's wait for it. It is saying there is some error. Okay. Runtime Node.js was deprecated. Yeah, so we can ignore this because it is a deprecation error. Let's try to run this function. So to run the function, you use sam local invoke. I think this is straightforward. And then you pass the function name. Okay, so it is giving it an error, which says that running AWS SAM projects locally requires Docker. Have you got it installed and running? So I have it installed. Let's run it also. Let's open Docker. Yeah, so now Docker is open. Let's minimize it. The engine is running. We can confirm. That's it. Just start Docker and then come here and run this code again, which is again sam local invoke and your function name, which you can copy from here. Let's say whether it runs or not. Okay. So it is giving some errors. It says cannot file module app. As I said, the Node.js cannot run TypeScript files. It 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 can just run JavaScript files. So to convert this, we need to build this. So we'll do that using sam build. So SAM build will build every function in your application. Let's wait for some time. So here you can see that it is creating a container and then running npm install copy source inside it. The build is succeeded. Let's try to invoke the function again, which is SAM local invoke and the function name. This also, by the way, creates a Docker container which runs on your local machine. If I go into containers, yeah. So you can see that we got a message which is hello world. Now this is also an API. So to test this API, what you can do is you need to start it as an API. So you can use SAM local start. Let me clear this. I think this is cluttered. So you use SAM local start API to start the API. Again, it will do the same thing. It will create a function for every, so create a container for every function and then start it. So it is giving us a URL. Let's go to that. Let's try going to this. It says missing authentication token. So as you can see here, we have declared the path as hello, and there is no path like slash. So for those paths, it will give us missing authentication tokens. So the path we have declared is hello. So let's try going to hello. It is loading, and here you can see hello world. Let me show you how you can make changes. So in app, you can come, let's say, instead of hello world, you say hello from Euron. Let's save it. Come here. So the thing here is that you need to build your app again and again after you make your changes. There is no hot reloading here. So let's build it. Let's see whether it, yeah. So a change got detected and it run the code again. It built the code again. Let's try going again. Yeah. So here you can see there is hello from Euron. Now this is just a very simple app. Let's try to add another one here. So to add a function, what you can do is that you can first come to hello world. Let's add another one. Let's say health.ts. So let's first copy paste this. Actually, let's just understand this line by line. So first we import these types from AWS Lambda because we are using TypeScript. We can ignore these comments. And then this is the main function, which is export. Just export const lambda handler, the event type which we have imported from it, and the return type, which is a promise. We do let response. This is the response object you are declaring. Then you use a try catch, which is simple. And then you just return it. So whatever you return in this function will be shown to the end user when it calls it. Okay, I think this is done. And also one more step you need to do is you need to come into template.yaml and then declare it here as well. So let's go here. We'll call it, let's say, health function. In type, we'll give it is the same. So let's give AWS serverless function. Is it right? Yes. Properties. The code directory is the same. So we'll give the same code URI, which is hello world slash. Yeah. So handler. Now the file is changed. Now the file is changed. So what is the new file name? It is health.ts. So let's say health dot lambda handler, the function name which let's cross check. Yes, it is lambda handler. Let's copy it so we don't make any mistakes. The runtime is the same, which is node. Let's copy this again. We don't want to make mistakes. Architectures, events. Let's name it something else, which is health. Its type is an API. It will be accessed across the network. Properties. Path, we need to declare something different. So let's say slash health so that it doesn't collide with this path. The method will also be same. Method will be get. Now we'll give it the metadata, which we'll just copy paste. This AWS handles for us, so we don't need to look no much into that. Let's change the path also here also. Let's say health.ts. Let's build it and see if there are any errors here. I don't think so. Okay, let me clear this and then SAM build. Yeah, so the build succeeded. So I think this is good. So let's try to invoke the health function. So we'll use SAM local invoke the function name. Yeah, so you get hello from Euron. Let's just change it to, let's say, to say that the server health is okay. So you put health okay. Let's build it again and then invoke it. Yeah, so you can see there is health okay. Let's start this as an API as well. So SAM local start API. You can explore these commands more to see configurations also. You can put the port as well, etc. So let's just copy this path. Let's come to the browser. We'll put this. There is no slash route here. So we get missing authentication token, but we do have hello, and hello returns hello from Euron. We also added one more, health. It says health okay. So this is done. So likewise you can create many apps, and I'll also show you how to deploy it. So let's say you have created this app. Let's say we want to put it on AWS. So there is a simple command SAM deploy you use. It takes some time, so let's wait for some time. It creates a chain set. So what is a chain set? Let's say you have already an app in the AWS, in the AWS Lambda. So it just check like what has changed, whether a template has changed, the code has changed, what has changed, and according to it creates a chain set. As you can see here, that the this app is whole new. So it just added everything in it and made it a chain set. It is asking whether we want to deploy these changes or not. Yes, obviously. Okay, so let's wait for some time. You can see that how much it is handling behind the scenes. We just have to enter a few commands and our app will be live on the internet. Yeah. So we just created the application in the AWS. So let's go to my AWS account and check if it is there. So you can come to Lambda. Here there are applications. Here you can see there is serverless X, which is our newfound app. Let's go to, we need the function URL. So let's go to any function. Let's say the health function. We go to API gateway and we copy this endpoint. Let's just run it directly. Yeah, here you can see that your app is deployed, and across this function URL, you can just query it. Let's also check the health, the hello. Yeah, there is a hello from Euron. So using these simple steps, you can just deploy your apps on the internet within minutes. But you might be thinking that if everything is this easy, then why should we even go with the previous approach, which is of the VM, which on AWS translates to EC2, ECS, etc. So I'll show you some cons as well of this, of serverless architectures. Let's go through them one by one. The first and the most important one is cost. So the cost per execution, let me clarify this, per execution is more for Lambda. So let's say you know that you are going to get 1 million requests every day and your traffic doesn't fluctuate a lot. Let's say it goes from 1 million to 1.1 million, 1.2 million. So for that case, Lambda won't be beneficiary because AWS is handling so much of our work behind the scenes. It will cost more per request. So it is better to run it on VMs like EC2, which has a fixed cost, which is less than Lambda per execution. So you can create a Node.js app. You can deploy it on EC2 if your traffic is measurable, if it is predictable. If you are a new, let's say, startup, a product, etc., the predictability of your use of the usage of your app is very low. So you can instead go for Lambda in this case. But after a while, let's say you start to observe trends that on this day there is this many requests. So you can just turn to VMs directly, which will help you save cost. Also, there is another problem, as I told you, that when a request comes to AWS, it first initializes the code and then runs it. This is called cold starts. When does it cold start? Let's say this is a function, let's say this is our health function. It hasn't been used for a while. So what AWS will do is that it will take this container and just spin it down, like just remove it. And whenever there is the next request, it will boot it back up. So this will take some time. Approximately, we can say that it can take around 3 to 4 seconds. So this causes extra latency. There is also a solution for this. You just deploy your apps in small packages, in very, very small packages. So what happens is that the time taken for this code to initialize, for this container to create, it is very less. So the user doesn't observe much latency, and also it is just for the first request. After this container is created, which is called warming in their language, in the language of software, after this container is warm, it doesn't spin down until and unless it stops receiving requests. It doesn't spin down until then. So this was the second problem, which is cold start, which you can solve by splitting your code into small pieces. And the third one is that it is completely stateless. Meaning, if let's say you have a Lambda, you get a request, And then using the information of this request, you need to write to a file inside that Lambda as a temporary storage. This is the file. You cannot do that. You will get an error saying that this is only a read-only system. So Lambda can read files, okay, but it cannot write to files, thus meaning that it is stateless. And also, there is no storage of Lambda. After the container spins down after its execution, whatever it has stored, it will be deleted. So it's better to not store any state in Lambda in any important state. There is also the solution for this is that you can use DB, any database for storing your stuff. For files, you can use EFS, which is the Elastic File System in AWS as well. So when you boot up a Lambda, let me show you. I can go to Lambda. I can select the application, the serverless X. Let's go to help function. And in configuration, you can see that there is a file systems option. So you can add a file system. First, you need to create it in EFS, which I will show you. Yeah, so here you can create a file system which is independent of your Lambda. So you can use this same file system across all the services like EC2, ECS, etc. Or you can use DBs to store data and EFS for big files, let's say. And also for object storage, obviously you have AWS S3. So you can solve this statelessness problem using this. And if you need stateless functions, then this is a perfect way to go. So I hope that you understood everything regarding stateless, why and why not should you use them, when and when not should you use them. If you have any questions, then I'd be happy to answer. Otherwise, we can just end the class. Okay, I don't think there are any questions, so we can end the class. Okay, thank you guys. Thank you for joining me, and I'll see you next time. Bye.